Hi, Ben with Novelux Stereophonic. Welcome to part 2 of the Altec 846B restoration. I'm here on site again at Sky-Fi Audio in Glen Rock, New Jersey. Thanks again to the guys for allowing me to use this beautiful space to shoot this content. If you want to give them some business, head over to skyfiaudio.com. They also have an awesome YouTube channel with some great content. If you missed part 1, you can go back and check that out. In part 1, I sanded down the cabinets, re-veneered the tops, and then refinished them in Danish oil. So if that sounds cool, go check out that video first. In part 2, I'm going to focus on reloading all of the components back into the cabinets. I'm also going to test and service the crossover plates, build a custom riser for the bottoms, and build some custom grills as well. So if that sounds cool, stay tuned, and we'll get these things reassembled. With no riser in place, if this thing is rotated around on a floor and one of the edges gets caught, it's really easy to pop up some of the veneer. So I'm going to get these risers built and put in place before I start any of the other work. I'm able to determine the original dimensions of the riser because there's some evidence left behind here. There's some pencil marks and also discoloration. So I'll be able to measure and get the exact dimensions of the riser itself. And then for the height, I measured my speaker and compared it to the spec sheet, and it's exactly 1 inch different. So we're going to go with a 1 inch riser and match the original dimensions here. So this is what I'm going for, roughly 25 by 17 inch rectangle miter joints with some just plywood corners in here for support. I was having trouble finding affordable 1 inch stock. And looking back, what I should have done is just bought a nice straight 2x4 and ripped it down. But what I ended up doing was breaking down a couple of pallets that had some nice pine bases and just ripped these down on the table saw into some 1 inch stock. So this is what I'll be using to build the riser. This is going to be almost completely invisible on the speaker, so I'm not too concerned about the nail holes and stuff like that. So I'll go ahead and cut some miters and get this assembled. I have my pieces dry fit in place. It's not perfect, but I think it's going to work. I'm ready to secure the risers to the cabinets, and I'm surprised at how well this held together. My initial glue up, I didn't think it was going to hold together this well, but it actually sits flat on there, and I think it's going to work pretty well. So what I'm going to do is drill 8 holes on the drill press, 2 on each one of the sides, and then I'm going to countersink that hole and put in a sheetrock screw. So I'm going to leave about 3/8 inch of this exposed. I want to make it nice and easy to remove. Before I secure the riser to the cabinet, I need to take care of this. Okay, what I'm going to do is line up the new riser with the fade line and the pencil lines on the back. I'm going to pre-drill just a couple of the holes. That one is not countersunk far enough. There's that one. So I'm going to try to countersink it a little bit more. If that doesn't work, I'll have to use a longer screw. Yeah, it's just not biting. I'm gonna need something longer. Okay, I found some screws that are slightly longer. All right, that felt good. All right. All right, that feels nice and solid. I picked up a bunch of these nail-on furniture spikes. So this is kind of what would have been on there originally. I think it was like a rounded metal equivalent of this. So I'm going to put one of these in each corner. Wow, that looks great. So now the speaker is just hovering off the floor, and look at how easy it is to move around. Awesome. The raw riser stuck out like a sore thumb at certain angles, so I just went ahead and painted black around the entire perimeter, and that should help it disappear a little bit. In preparation for reloading the components back into the cabinets, I need to tackle these crossover plates. So this one I've already been through. I physically cleaned it, polished the knob, took apart and cleaned the wire wound control, tested the capacitors. Everything is good on this one. All it needs yet is a frequency response plot to verify operation. On this other one, we'll go through this together on camera. I'll go through the cleaning process and all of the other steps. And then when they're done, we'll hook them both up to a load and compare them to see if they have the same frequency response. I'm going to start off by removing this knob so that I can thoroughly clean the knob and also extract the wire wound control. Looks like this is a hex set screw. I believe it's going to be 5/64. Yeah, that's it. So on this one, I don't really need to index anything. When we put it back on, we'll just make sure when it's rotated all the way to the left that it's on the 10 mark. Okay. All right, that knob's off. This is interesting. It's a knurled split shaft. You'd expect on a control with a set screw or knob with a set screw that you'd be going to a solid shaft, but you can see kind of some of the compression there. So I'll have to be careful not to over tighten when we put that back on. The main thing that needs to get done on this is cleaning the wire wound control. These were both, when I did initial testing on the speakers, these controls were really scratchy. So we'll go ahead and take care of that. I'm just going to use an adjustable wrench here on the nut. This one, the knob is pretty big and covers most of this plate, so I'm not super concerned about accidentally slipping and scratching that area, but a lot of times I'll use these rocket sockets in this type of situation just so I don't cause potential damage to the metal. All right, I'll set these aside. And I should be able to get this control spun around. So that washer goes there to keep it from spinning. So on this control, it's like a, I don't know, ceramic or porcelain base or something that everything is built on. I just need to bend these up to gain access to the control itself. So for this step, I'm just using a sharp flush cutters. This is a cutters that I've used for prying type work before, so it's a little bit bent. I have a yellow handled one that's not bent that I use for the majority of my work, and I reserve this one for doing work like this so that I don't mess up the teeth on my good one. It's important to be kind of delicate with this step here. Too much bending of these back and forth can cause them to snap, and then the control won't hold together anymore. So this plate should be able to come off the back, and then I'll straighten out these tabs. Okay. So in preparation for reassembly, I'm just going to straighten these out. Okay, let's take a look at this control. So this is a wire wound device that can handle quite a bit of wattage. We've got one contact here on the outer ring, and then the other contact is on the inner ring. I'm actually going to, this is really, really hard to turn by hand on that tiny shaft, so I'm going to reinstall the knob because I'll need to manipulate this control as we clean it. I'm just trying to find the same spot so that I don't put an extra divot in this shaft. Okay, and where's my hex driver? All right, that additional rotational force makes it much easier to turn this. So what I'm going to do here is first clean this with alcohol, and then I'll come back with a concentrated deoxit to get this smoothed out, and that will kind of lubricate the surface so it's a little bit easier to spin and make it so that it's not scratchy anymore. I'm starting out with 99% isopropyl alcohol just to kind of get any surface crud off of the wire elements. And it's not super dirty in here, but these wires I think get tarnished, or the contact on this, it looks like brass, can sometimes get a little bit dirty or corroded, and then it has trouble making contact. So we'll rotate this over so that I can get the next portion. Okay, let's do the inside one. Okay, so that's looking better already. I'm going to come in next with a very light application of deoxit D100. This is the 100% concentrate in the applicator. I don't like using a spray on something like this because it's just going to get all over the place. If all you had was D5, I'd probably spray a little bit into a cup or something and then still apply it with a cotton swab because we don't want to over lubricate this thing. So I'm going to start with this all the way over on one side. And I'm just going to saturate the tip of this cotton swab with the deoxit. And then just go all the way around, kind of the same as we did with the alcohol. And this should really help to clear up that scratchiness on the inside of the control. What you definitely don't want to do on a control like this is try to find a hole to enter with a spray or do something in this. It's just going to make a huge mess on the inside of the thing. Kind of have to just keep rotating this to expose the untouched area of the inner winding. And we also want to make sure that this junction into this spot is really clean. This is where the output or input of the control is. Let's see, where else do we need to look here? And this looks like this is soldered, so that should be fine, making the connection to here from this inner ring. And then the last part, I just want to put a little bit of deoxit right on the not on the top there. I want it to be kind of in between. So to just get it right in between this area here, and then take the control around to basically just try to clean the tip of that contact area. And you can see I've got a little bit of extra deoxit there. Try to get that out. I don't really want to leave a whole lot behind on this wire, but just getting that cleaned is already freeing up the action on the control. All right, let's do the inner one same way. All right, that's turning nice and smooth, and hopefully will be scratch-free when we test it. I removed the knob to give me a little bit more room. This piece is symmetrical, so it doesn't really matter which way it goes on as long as you get these little tabs in that little slot there. I'm just going to get them close to where they need to be and then bend them in with the pliers. So I find, for me, the best tool to use is something like this. This is a 45-degree electronics pliers, and it just seems to give me the right angle and the right leverage to get down on here and fold that over. And then I'll come back with a slightly bigger tool in a second and just clamp it down once I get them all formed into position. So I've got lock washer, and we'll feed this back through. And apologies for my ugly hands in this video. It's just extremely dry at this time of year, and I was playing with my cat and it got a little bit out of hand and I got some bad scratches. That's what that is. So apologies for having to sit through looking at my ugly hands. All right, let's clean this up. For this, I'm just using Windex and a toothbrush. I use Windex for almost all of my metal cleaning. It has a little bit of ammonia in it, which does wonders for cleaning metal surfaces. I'm sure some of you with more Altec experience can tell me what this and this marking here mean. So if you know that, if that's a date code or something, please post that in the comments. Be interesting to know. All right, let's test these caps. 8 microfarads, 75 volt non-polar. Like I said earlier, I think this is some sort of electrolytic, but the ones in the other one tested extremely well. It has me thinking that it's film, but it looks like it's too small to be film, but maybe the low voltage is the key. In any case, I'm going to desolder this connection here, and we'll run this on the Sencor LC102 and see what it's looking like for value leakage and ESR. Let's start out first with the Peak Atlas tester. So just my go-to capacitor tester for really anything above 1 microfarad. So 8.7 microfarads, very low ESR. So this cap is fine. We'll get the other one prepped and then we'll test them both on the LC102 at the same time. This one says 21 microfarads, 75 volt nonpolar. On a film cap, you wouldn't even mark it nonpolar, so these are almost certainly going to be electrolytic, but you guys can leave in the comments and correct me if I'm wrong. Yeah, very, very close to the value it's supposed to be. Let's check them for leakage on the LC102. I'm hooked up across the 21 microfarad one. Let's see what it gives us for value on this tester. Oh, that's not correct. There we go. So this is saying 21.3, 21.4 microfarads. Let's check the leakage at 75 volts. It's saying it's good. I'm going to wait and see if this comes down close to 0. So it seems like it has a little bit of leakage, and this is more evidence that it is an electrolytic. On a film cap, this would come down almost to 0 if it was in good shape. Here's a 22 microfarad 63 volt cap. I just want to throw this on as a reference. Okay, so I got this one in the tester. The value, and let's see the leakage. So it's coming down a little bit faster, but you can see that the one that's in there is probably fine to stay. One of the things that I am going to update on these is the way that the speaker connections work. These have these spring-loaded connectors, but they're limited on gauge. You can't really fit anything bigger than 16 gauge in there. And if you try to convert to banana with like a little adapter thing, it puts a lot of stress on the connector. So one of the best things I've seen is a bare wire to female banana dongle, and I think I'm going to make a couple of those up. So what I picked up for that is some red and black female banana connectors. These are really like test jacks, but I think these will do well with a wire solder to them and some heat shrink. So the part numbers here are from Mauser are 530-108-2302-1 and then 2303-1 for the black. So those are the parts I'm using for this. So I'm going to make those up quick to make the interface at the bench a little bit easier. So I went through my stash of hookup wire and I found this little gem here. This, I believe, is a piece of transparent in-wall speaker cable that is just like a cut off or wasted end from something at some point. And this solders up really nice. It's really high quality copper. So I'm going to use this to make up these little dongles. What I'd really like to do is tin this wire so that it's protected from tarnish, but it's just on the edge of being able to fit in this connector. So I think what I'm going to do is just seal off the end so it doesn't fray. And maybe I'll try a little sample where I just tin it up quick and see if it still fits. All right, let's see if this can still go in there. Ah, it's perfect. So that's going to be the ticket there. So I'll prep a bunch of ends like this so that they have this little short tinned exposed section here to go in, and then the other end will get one of these female bananas soldered to it, and I'll put a little piece of heat shrink on there to make it look pretty. Okay, this is what I came up with for my little banana dongles, and I may have been mistaken about the cable. This may be Kimber. I just don't remember. It came from some audio job where I was running cable through a wall. It's just been so long ago I can't remember. In any case, I'll hook a set of these up to each of these plates, and then I can interface them more easily with banana connections. Here are my fancy new dongles hooked up with a banana connection to the patch panel over here. What I'm doing is feeding a test signal from my signal generator here. That's going into this Macintosh amplifier here, which is putting the output into the crossover. So that comes back, comes into the crossover plate. And then each one of these outputs is connected across an 8 ohm dummy load, and we're monitoring that on the oscilloscope up here. So what we're looking at here on the scope is the woofer on the blue trace and the horn or the tweeter on the yellow trace. So I'm at 1 kilohertz right now. We're fairly equal on output. As I increase this 1 kilohertz at a time, you'll see the bass drop significantly. Right now I'm at 4 kilohertz. And once we get up to around the 8K mark where the crossover is rated, it should flatten out and stop increasing. And we are seeing a slight decrease starting at around 12K. And then once we go, right now I'm way above 20K. You can see the frequency here. So we can see it drops the higher you go in frequency. And then if we go the other way, we'll have the opposite effect. So I'm going to drop 100 hertz at a time. So right now we're at 900 hertz. You can see the woofer increasing while the tweeter or the yellow trace decreases all the way down to 100 hertz or so here. And we can see there's almost no signal on the tweeter, which is what we'd expect. So I'm going to run this on a Bodhi plot. It's a much better way to look at this type of device. So I'll get that set up and we'll take a look at the plot. Here are the results of the Bodhi plot on this crossover. This is with the attenuator at 0 dB. So we can see the bass here comes up to around this point and then starts coming down. And then we have the opposite for the treble. It is around somewhere around this area. It starts sloping downward. And the model number of this crossover plate is N800-8K. I'm not exactly sure what that means, but just looking at the plot, what it may indicate is we have 10, 9, 8K around right here. Maybe that's where the filter starts for 8K, and then maybe this filter starts at around 800 hertz. So that could be the nomenclature. I'll have to look into that a bit further. But my main concern right now is, are these plates equal? So I'm going to take a screenshot of the scope for this and compare it to the second crossover, keeping everything equal. So these look pretty darn close. They might look different in where they're positioned on the screen, but the shapes are the same and the frequencies seem the same. So I think these are good to go in their current condition. They're both doing what they're supposed to do, so these are good to get loaded back into the cabinets. So the last thing that I wanted to show while we've got these at the bench is the attenuation. So this is that control that we cleaned. Right now this is at 0 dB. That's where I did the Bodhi plot testing. And then we have the ability to rotate it down to -10 dB. And right around that area, around the -10, it must hit the end of the track and completely cut off. So I don't know if that's by design that you're able to completely cut the tweeter, or if the control's just old and when you get to that range, it just hops off the end or something. But anyways, this is the control that we cleaned. So all the scratchiness is gone. It's nice and smooth. And what we can imagine, if you were looking at the Bodhi plot and we saw that curve that kind of came across the scope like this, as we adjust the control down, imagine that entire line just coming down together. The shape stays the same, but the entire line just comes down in amplitude. So if we think we're getting too much horn while we're listening, we have the ability to back off the horn relative to the woofer. Now that I've tested and verified the crossovers, I can reload all of the components into these cabinets. Next up, I need to interface the compression driver with the horn. Let's see, which side do I want up? I guess I'll do the 811B horn writing upwards. This gasket's still in good condition. Now, I can't remember how I pulled these out of the cabinet. The Altec logo is going to be upside down because I want the connections to come in from the bottom. So I guess I can always turn it around if I want, but it shouldn't make that big of a difference. From the pictures that I took, the orange wire goes towards the terminal by the Altec C. So I'm going to lift this into position and install the orange wire here and the black wire here. Okay. Come on. Okay. These speakers appear to be missing a lot of screws, so I'll probably get all new hardware. There's 6. Oh, is that a hole? Yeah, I think there's 6 mounting points, but I only had 4 screws per horn. So I might go back and add some more screws at a different date. Before I load this woofer baffle back into the cabinet, I need to remove the woofer and use this baffle as a template so that I can make up my grill. That's weird, I've got mismatched screws here. This last one's a flathead, so I'll probably end up getting new hardware for this anyways. I'm going to be making the lower grills out of 1/4" MDF. I've already got this piece cut to size, but what I'm going to do is flush it up with this bottom edge. This is going to sit kind of right on the lip in the bottom of the cabinet, and then I'll put this upside down and trace out the circles that I need to cut out of this board. Now that I traced out the baffle onto my grill blanks, I can load this woofer baffle back into the cabinet, and my pictures showed that black goes to black, green goes to red. Interesting. When I connected that, I heard a little pop. There must have been a little bit of energy stored in one of those crossover caps. Now, same thing here, I'm missing some screws, so I'm just going to put enough in here to hold it in place. That's the easiest way, probably like this. Okay. That almost just holds itself in by the way that the weight works on the driver. So I'm just going to throw in a couple screws for now, just to get these up and running, and then later I'll come back and change out all the hardware. Got all of the components loaded back into the cabinets, and I'm just going to sit down and do some listening. One of the things that I picked up for these was these cool foam surrounds. This is from an eBay seller. I'll try to leave a link in the listing, but this is a foam surround that can go around the horn, and I think it tames it down a little bit. But I want to get a reference before I put those in, because I want to see if it actually makes a sonic difference that's perceptible. In my initial listening on these speakers, just getting used to them, something sounded a little bit harsh and I couldn't quite identify it. I backed the horn down to -5 dB, which helped a little bit, but there was still a little bit of harshness. I ended up loading in the foam just to see if it would make a noticeable like night and day difference. I didn't really notice a whole lot of difference, but as I continued to listen to the speakers and got used to their sound and increased the volume a little bit, listen to them a little bit louder, they started to sound really, really nice. So I'm not able to comment on whether or not this foam made a huge sonic difference, but it definitely makes a visual difference. It just kind of completes that look on the front. Everything kind of seamlessly goes together, and this is really going to work out well with the half grill that I have planned for the bottom section. Before I go too much further on these, I want to correct the hardware. So a really good friend of mine that's worked on Altec speakers for forever had a huge stash of original hardware. So he hooked me up with all of the front baffle screws, and the extra horn screws and stuff that I need, and I'm even going to replace the screws that hold the woofer to the front baffle. So I'm going to go ahead and take care of that now. So this is the baffle that we looked at earlier. 3 of the screws are like a truss head Phillips, and then the other one is a flat head. So these are not original screws. These should be the correct screws to go in there. This baffle will look a little bit nicer with the correct black screws installed. With all of the hardware correct, I can move on to the final touch, which is going to be the grill. So originally this would have had a 3-dimensional foam grill that would stick out, that would cover the entire speaker system. But I really like the look of the horn, and I like looking at this foam that I put in here, so I'm just going to do a half grill from here down that just covers up the woofer. This is a grill from Eclipse Forte. I believe they call this lamb's wool. And I think that's a really good match. These colors seem to really blend. This is kind of a classic 1960s combination. So even though this is a 70s speaker, I think this is the look that I want to go for. So what I'm actually going to do is order in some linen from a eBay seller that kind of tracked down the fabric that was originally used on some of the Dynaco products. And I just did a set of Dynaco A25s that came out really, really nice. I think that's what I'm going to go with. So let's go ahead and get these grills built. I ordered something new for this project, this circle guide kit. It's basically like a router attachment that allows you to cut really precise circles. This thing worked great. I used a piece of scrap MDF that I had left over from when I had the grill blanks cut out. Look at that. I just set this thing up to trace the line that I had drawn. It came out perfect. And it looks really great on both sides too. So that turned out really nice. I was going to use a hole saw for this, but I think I'll just set up that jig to do this, because with the router bit, it just comes out so clean. So while I've got it set up to cut the big circles, I'm going to get those cut out of my actual grill frames, and then I'll set up and cut the 4 smaller circles for the ports. So the first thing I need to do is mark the exact center of this circle. So this is an interesting trick that I just learned from a YouTube video. I'm going to draw 3 lines. In this case, I'm drawing them at 12 inches long and then putting a mark at 6 inches. And I just need to do this in 3 different places. Okay, so I have 3 12-inch lines there with the 6-inch center marked. Then you can just take a piece of paper to act as a square, and I square it up with this line. And then draw across, and then where these 3 lines intersect should be the center of the circle. Now this is the first piece from the jig, and I just need to get this screw lined up on my dot. Let's check it. Yeah, looks good. Okay, so that's going to be the pivot point for the jig. I have my little edge router installed. This is supposed to be done with a plunge router, but this works just fine. So I've got this all aligned inside of the jig. There's YouTube videos showing how to get this all set up. So I've got this kind of aligned because I already did my test circle. This is the pivot point here. So I just need to put this on the pivot, and then I'm going to check the alignment of my bit around the circle and make sure everything looks good. So I have the edge of the router bit kind of aligned on the outside of this circle. And all I have to do is lower the router bit a little bit, drop it in, and then just go around a few times, lowering it a little bit at a time until I cut all the way through. Both of the large circles are finished. I did a quick test on my blank piece for a smaller circle, and I have to be more careful on this one. When I got all the way around, cutting through, it jumped on me and I got this little notch in here. So I just have to be really careful and slowly approach the point where it's going to cut through. But other than that, it should go well. So I have my centers marked on this one. I'm going to go ahead and set up the small jig and cut these two holes out. So on this one, I put a bunch of downward pressure on the jig and then I had my hand on the button. And as soon as I felt it free up, I turned off the router and that seemed to do it. My friend Lou just stopped by to say hi, and he gave me this awesome tip, and I'm upset I didn't think of it myself. But what he said was, on making up grills like this, if you leave the circle edge sharp, when you pull the grill cloth tight, sometimes it can leave a line. So the solution is to just route a little corner in. So I've loaded in this, this bit, and I'm just going to go around each one of these and round off the edge a little bit. Here's one with the straight edge, and then this one has the rounding on it. So I'll go ahead and complete this step on all the remaining holes. Here's the completed grill with the edges all rounded off. This is the fabric that I'm going to be using. It's this nice patterned linen with the lines. So the first thing that I'm going to do is cut this to the proper dimensions, and then you can see it's wrinkly. I'll need to iron this all before I stretch it onto the grill frames. So I'd like to leave about 4 inches or so on all of the sides so that I can stretch and glue this down. So I just need to make a cut right up here, and I'll keep the width of what it was shipped. It's just going to be a little bit long on this side, but I'm going to be cutting it off anyways with the blade in the end. So I just need to make one cut from here all the way across. I'm really glad I didn't just start gluing this up. What I noticed when I dry fit this is that I'm going to be able to see the brown from the MDF through the linen. And also, even if I stretch this tight, I think I'm going to get a difference in coloration around the edge, because this kind of just goes into, I guess, blackness, both for the woofer and here, and I think you'll see the holes through the grill. So what I came up with was using a different fabric first. So this is a black fabric that I got from Parts Express, and I just went ahead and whipped one of these up quick. So this is the other frame for the other speaker, and I've got the black acoustically transparent cloth on there. And then when we lay the linen down, it's a nice uniform look. and it'll darken it up a little bit too because it's got the black background. So I think this will turn out really nice. This is what I'm going to go with. The first thing that I need to do here is put a bead of adhesive all the way around the edge. This is the flat side, so this is going to be the back. And I'm going to be using this DAP Weldwood contact cement. This is a method that I picked up from Simply Speakers, I believe. Making a bit of a mess here. I'm just using my middle finger here as a guide so that I'm about, I don't know, between a 1/4 inch and a 1/2 inch from the edge. And I'm just going to lay down a bead of glue here. Once that bead is done, I'm just going to go with my finger and spread it flat. And then I need to let this tack up. The adhesive's now plenty tacky, so I need to start with one of the long sides. And I'm just going to fold the top over here. I mean, it's surprising how well this sits. You just have to put some pressure down. That holds that nice and tight. And then here, I'm just going to give it a bit of a stretch. I'll start in the middle. I just want a nice even pull. Okay, and the sides. And this is going to be a little bit more challenging when I do the linen because it has a pattern to it. This black acoustically transparent material is pretty forgiving. All right, looks like I got a little water there on the table or something, but that turned out pretty nice overall. So the next thing that I need to do is cut off the excess from the black material so that I can install the linen. So what I'm going to do is use just the width of this ruler, it's about the overhang that I want, to set up a straight edge, and then I'm just going to go through the whole thing with a razor blade. I just put a fresh blade in this utility knife. So let's see how this works out. So I'm just going to use this ruler as a gauge to get this placed where I want. And I'm not going to cut all the way to the edge. I'm going to do the edges with the scissors a little bit later. So that's kind of where I want that. And let's see how this works. Stop right about there. All right, it's not the cleanest cut, but it's nice and straight. So I'll go through and do this on all of the other edges. So now for the corners, when we do the linen part, I'm actually going to use a staple gun and kind of pull the corner tight. But on this is just a base layer to kind of keep the color correct. So I'm just going to cut in almost like you would a miter joint. I'm just going to cut this into a triangle and glue this down before we do the next step. I've got all my corners kind of prepped. Now I'm going to put on some adhesive. And this panel I had done a little bit earlier, I'm glued really close to the edge. So what I might do is put another bead here and get this excess glued down so that it's not flapping like this, because the next layer is going to come over the top. So right now I'm just going around and getting all this excess glued down and then gluing down the 2 flaps at the corners as well. And I can use kind of this line. The mark that I've made with the razor blade, I'm using that as a guide on where to place this mostly cosmetic glue bead. So now with all these corners glued up, I just have this little thing here, and this is just keeping it from fraying at the edge. When I bring in the next layer, this is just going to get pulled underneath the linen, so I'm not even going to glue this down or anything. This will get pulled down flat, and the linen will get stapled in this corner, so I can move on to the next layer. I think what I'll do, because I can't really come too much further past this, I think I'm just going to put the bead right on top of the existing fabric, maybe right on the junction. That'll help tie this down. So maybe I'll run the bead right on the edge, and it'll be a combination of sitting on the other fabric and on some fresh parts of the MDF. So let me lay down that bead and let that tack up. Let a couple minutes go by, and this is getting pretty darn tacky already. And this is going to be the hardest part here, is getting this linen to sit on without distorting the pattern. So I'm going to do one more try at positioning. Make sure this is nice and flat. Okay, I'm going to go ahead and stretch this and try to get it to adhere this way. See how it's kind of bunching up here? It's hard to get this nice and tight without distorting it. So I'm going to try to evenly pull as I go here. And we're going to see what this looks like when I flip it over. It needs to be nice and tight. So I'm just taking parts that I'm noticing are not stretched as much as the other parts, and just giving it a little tug and then a push down on the contact cement. Okay, that's feeling pretty good. Now I need to go to this side. My problem is I need to make sure that I'm not distorting this pattern. So this is going to be kind of a dance between the front and the back. Lay it back down nice and tight. Fingers crossed. Yeah, it's hard to tell. This side looks pretty good. You stand to do a little bit more there. Yeah, this is already down. I think I'm going to have to go with that. This is already starting to set up. So best I can do now is just pull tight on the edges. So we'll give this a shot. Fold this back. We'll do the corners kind of separately. You see here I had to put my adhesive on here because I'm so close to the port cutout. All right. And if you look here, if I pull too tight, it's going to start separating here. So it's kind of a, kind of just have to do it by feel. All right, let's see. That's actually starting to look really good down there. Let's try the other side. I'm just going to go for trying to keep this about the same tension as I have over there. Yeah, this is not actually turning out that bad. For the corners, I'm going to be trying a Milwaukee staple gun with 1/4-inch staples. And the idea here, we don't have any adhesive pulling this tight. So we're going to use kind of a twist that's going to pull it tight on this edge and this edge. So I just have to kind of get the fabric into a point where I can twist it and get both of those edges tight, and I don't want to over tighten it because this is going to be the top edge and it's going to be visible in my cabinet. So if I overstretch it here, you're going to see like an opening and black underneath it. So I have to be pretty careful here. And then the other thing is I don't want a big bunch of fabric here. So I want to try to keep the staple kind of close so that I can cut off a bunch of the excess. I'm going to add one more staple at each of the bottom corners just to kind of prevent this from fraying more. Okay, here's the completed grill. Looking acceptable from the back. Front is looking good. And one of the things that I can do here, this has got like a little spring to it. If I was to spray this with water, just mist it with water and then hit it with a hairdryer or something, it'd help pull some of these fibers tight. But I think it looks okay. I think I'm going to run with that. So let's get it loaded up on the speaker, see what it looks like. Thanks again to the guys at Sky-Fi for allowing me to use their space for the bulk of this restoration. I now have the speakers back in Manhattan, and it's time to put on the final touches. So here's one of the completed grills, and the way that I cut this blank was to be pretty tight so that when fabric got put on it, it would be able to just be pressure fit in place without any Velcro or anything. So this will be really easy to take in and out. Look at that, it turned out great. The cherry on top is going to be a reproduction badge. So I just made up this quick little template to help me square this up. All right, let's take a look at the finished product. I am thrilled with how these speakers turned out, both sonically and cosmetically. They're really a pleasure to listen to. I'm excited to get them into a bigger space. They'll be a lot more enjoyable when I have a little bit more room to play with and I can get them away from the walls a little bit. But cosmetically, they're just fantastic. I'm super happy with my grill choice. I have in front of us kind of a representation of the type of equipment that I tend to use. So I've got a Pioneer SX1250 on the top, an SX1980 in the middle, and then a Marantz 7 preamp on the bottom. And both of these types, 1970s receivers, Silverface and Walnut, blends in perfectly with the grills, and so does the 1960s Champagne anodized aluminum. So I'm really happy with this grill choice. I think it's really going to vibe with the type of equipment that I really like to own and enjoy. So thank you so much for coming by the channel and checking out this restoration. It was a super fun project. I'm sorry it was so drawn out, but there were a lot of steps. So thanks for sticking with me. If you enjoyed this content, I'd invite you to like and subscribe. But for now, let's take a listen.